The Leave plan of stargazers has found that, utilizing our new $10 billion toy, it will be years before that task turns into a reality. If everything goes as planned, the excursion to Proxima B will take around 20 years. Therefore, it will be quite some time before we can confirm if there is indeed life on that planet. The age-old question of whether we are truly alone in this universe continues to persist. The James Webb Telescope has found some alarmingly humanesque things far away from Earth that bring us closer to the answer. Our quest for life beyond our planet has been widespread throughout every human civilization, to the extent that we have a multitude of media, writings, and hypotheses regarding this matter. Our miracle regarding our place and loneliness in the universe has been constant, as though it is ingrained within us to constantly seek a companion, no matter how alien-like it may be. We may be getting increasingly close to the responses we genuinely need, but are they truly the answers we are searching for, or are they significantly more startling? Join us as we explore the latest discoveries in the realms of systems and planets on the journey to find something we might not be ready to observe. Lights in the distance have led scientists to what could be the most notable discovery in history. Back in 2021, when the James Webb Space Telescope was planned for launch, a very intriguing speculative inquiry was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet, such as Proxima B, the nearest exoplanet to Earth. Proxima B, located about 4.25 light-years away, was believed to be tidally locked, with a permanent dayside and nightside, much like our moon. A speculative technological civilization on Proxima B could transfer heat and power from the dayside to the nightside using photovoltaic cells that generate energy from starlight. In a paper co-authored by Manasvi Lingam, it was shown that significant illumination of the dayside by solar panels could be detectable with future telescopes. Since the JWST is more advanced, it would allow us to broaden our search for artificial lights on potentially habitable exoplanets like Proxima B. Now, in 2024, the James Webb Space Telescope has made this possible. Using its higher sensitivity and greater range of capabilities, the JWST could have detected the lights we were searching for and potentially propelled us into a new wave of human advancement. Above all, let us dive into the universe of planets and exoplanets to understand how this is indeed possible. James Webb's mission to uncover Proxima B's mysteries. For centuries, humanity has pondered the nature of the universe. Who we are, where we come from, and where we are going. These are fundamental yet incredibly challenging questions that we have tried to answer since we gained consciousness. In this era of remarkable technological advancement, one wonders whether we are any closer to addressing these inquiries. If you were to ask a philosopher, they might say we are still at level 0 in understanding ourselves within the universe. However, if you ask an astronomer the same question, you would likely see them bounce around with excitement as they rush to tell you about the latest discoveries made by scientists about the universe using their sophisticated tools. Although these tools have not received much attention from the general public, they are clearly a testament to human advancement itself. We now have the world at our fingertips, and it is time we push forward to access the universe as well. One such method has been proposed by researchers and space experts through the technology we harness. A specific application of this technology is currently responsible for the recent discovery of what may be light on another planet, light-years away. Yes, we are talking about the James Webb Space Telescope. The James Webb Space Telescope is a creation born out of the legacies of human endeavors in space to answer several enduring questions. Are we alone? Who else is out there? Where do we start and where do we end? This infrared astronomy device has already begun addressing these inquiries. You might ask, what exactly is Proxima B? Proxima Centauri B, or simply Proxima B, is sometimes referred to as Alpha Centauri CB. It is a super-Earth exoplanet that orbits an M-type star. Super-Earths might confuse you, but don't worry. This text will answer all your burning questions. Super-Earths are a class of planets that are larger than Earth but smaller than ice giants like Neptune and Uranus. They can be composed of gas, rock, or even a combination of both, and their sizes can vary from 2 to 10 times the mass of Earth. They truly put the super in super-Earth. Proxima B is classified as a super-Earth and an exoplanet, meaning that it orbits outside our solar system. The first possible evidence of an exoplanet was discovered in 1917, although it generated little interest and recognition. In 1992, the first confirmed detection occurred, leaving researchers puzzled. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Among these, 896 systems have more than one planet. These remarkable discoveries are orbiting an M-type star. To explain M-type stars, we must understand red dwarfs. A red dwarf is the smallest type of star in the main sequence, hence the name. In the neighboring regions of our Sun, red dwarfs are by far the most common type of star found in the Milky Way. They have very low luminosity, and since luminosity is one of our primary tools for planet detection and other types of classifications, red dwarfs are not particularly easy to observe. These elusive stars have variable definitions and names based on their temperatures and sizes. For example, M dwarfs or M-type main sequence stars yield a maximum temperature of 3,000 K, which explains their name and characteristics. Returning to Proxima B, its mass is known to be approximately 1.07 times that of Earth. Interestingly, it takes only 11.2 days to complete one orbit around its star, compared to our 365.25 days. You can estimate the size of the star Proxima B is orbiting by observing the entire electromagnetic spectrum. The star has a total luminosity of only about 1.6% that of the Sun. In the visible light spectrum, its brightness appears even dimmer. It emits only 5 to 6% of the Sun's brightness in the visible light range, radiating significantly less light energy compared to the Sun. More than 85% of its emitted energy is in the form of infrared radiation. The discovery of Proxima B was announced way back in 2016. You might wonder why Proxima B is so significant. With countless stars, planets, and galaxies out there, why are we so focused on this particular celestial body? Well, several reasons contribute to the strong fascination astronomers have with this place. First and foremost, Proxima B is the closest known star to our Sun. While 4.2 light-years is a significant distance for us Earthlings, in the grand scheme of the universe, it is a mere blip. This is why Proxima B, our nearest known star, is high on our priority list. Additionally, Proxima B is part of a triple star system called Alpha Centauri. Despite Proxima's low luminosity, the system itself appears as one of the brightest star clusters in the night sky, ranking just behind two others called Sirius and Canopus. However, the most intriguing aspect of Proxima Centauri B is its potential habitability, as it lies within the habitable zone. The possibilities surrounding this star are endless, which is why astronomers have taken on the mission to explore the depths and limits of its potential. That is where the James Webb Space Telescope comes in. The four critical objectives of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, understand star and planet formation, and explore planetary systems and the origins of life. As the JWST continues its investigation of this exoplanet, we get closer to fulfilling these missions, from searching for exoplanets to seeking extraterrestrial life. So, what exactly does this mean? Given that humans have always been a curious species, probing and poking into everything under the sun, whether it moves or doesn't, it makes sense that a mission like the Search for Extraterrestrial Intelligence, SETI, came into existence on such a grand scale. Imagine if God orchestrated a great infinite expedition, but with a twist of gold. We are entrusted with being on the lookout for signals, more specifically, electromagnetic whispers from civilizations beyond our imagination. SETI, short for the Search for Extraterrestrial Intelligence, is akin to the world's highest stakes game of hide and seek, with our planet as the seeker and the vast universe as the seemingly limitless hiding place. It is one of those fields where researchers are modern-day Sherlocks, tuned into radio waves and scouring for that elusive hello from another world. This astronomical snooping began decisively in the 1960s when Frank Drake, a man who could make even Einstein say, "Well, that is a clever treat," pointed a radio telescope at two solar-like stars and tuned in. Although he was met with silence, Drake's equation, a mathematical formula to estimate the number of civilizations in our galaxy, has laid the groundwork for generations to come. Fast forward to now, and SETI has evolved from a backyard science project into an interstellar undertaking. Researchers utilize a variety of instruments, from radio telescopes to optical devices that can detect laser signals, to comb through the cosmos for signs of extraterrestrial civilizations. And guess what? James Webb's infrared capabilities can also complement these endeavors, as any interstellar tech could illuminate in the infrared spectrum. The quest for knowledge about the stars continues. As we pursue answers about the universe, we find ourselves peering into the unknown, stepping boldly forward with each new advancement in technology. The James Webb Space Telescope allows us to open a new chapter in the story of humanity. The ultimate question remains: what will we discover in the dark? Could it be that we are not alone, that there are others out there in the vast expanse of the universe?